Hey, everybody, it's good to be back. So, I wanted to just dive right into what I think is the biggest news in AI in the last week. And that is, and I'll unpack this. So, let me just start with the claim. And that is, I think that OpenAI has solved generalizing outside of the training distribution. Now, that might sound like a very Byzantine kind of like arcane set of assertions, but if you know what that means, you're probably losing your mind right now. And if you don't know what that means, let me explain it for you. So, up until now, whenever you train an AI model to do something, it's really good at the things that you train it to do. That's when you see the little charts that say, like, here's the loss function. And I'll show you some of those graphs in just a second. But when you have that loss function, basically you're saying, how close does this model represent the data that you've given it? Which means that it can fill up and within that distribution, so that data set that you train it on, that's the training distribution. So it can fill up and say everything that is inside that data set, it can learn how to do. But up until now, it's been kind of an open question as to, can these things actually generalize beyond their training distribution, which is basically that's what allows them to think more like humans, where it's like, well, I have some like, first principles knowledge. I have some other experiences. So let me translate everything that I know and let me triangulate some other facts and other things that might be true because of what I know. Now, I have been using these models for a while, and this is one of those emergent capabilities. And if the rumor mill is correct, and I'll leave it at the rumors for now, then it sounds like O3, which should be coming out, in about a week or two, according to the rumors again, then O3 takes this to the next level. So O3 is OpenAI's upcoming model, which I think basically everyone agrees that O means like Orion or whatever. Anyways, it doesn't really matter what it means because they've got their naming conventions all screwed up. It's their next generation reasoning model. Now, I've got some people that I know that have gotten early access, and I don't want to give any specifics, and honestly, they won't give me any specifics either, because those with early access, I think they had to sign an NDA or something. Anyways, they get the vibe that they give me is that O3 is very clearly beyond AGI. It can solve any problem that you can give it, and actually, people, even smart people that I'm working with, when they get access to O3, they're saying, I actually don't know what the limits are because it can do everything that I've asked it to do. So that will probably, if your definition of AGI is not already satisfied, then O3 probably will satisfy it. Now you might say, okay, well, if the video is like, we're only 3 steps from ASI, then you might say, well, Dave, what's your definition of artificial superintelligence? My current working definition of artificial superintelligence is we will have achieved ASI when human intelligence is no longer a constraint on any scientific or economic activity. So that basically means human intelligence is no longer a consideration. So that's the first part of today's video. Now let me unpack the graphs. So I laid this all out in this tweet, but what you really need to see is the visuals. So the primary thing here, let's actually start with the end and work backwards. So this graphic came from Ethan Mollick. At least that's who I saw reshare it. I don't know I think he made it. But let me explain what this graph represents. So Ethan Mollick is really big over on Substack talking about AI. Definitely recommend that you follow him. This represents the benchmark GPQA, which is Google Proof Question and Answering. So basically what they did was they took a bunch of experts and they said, okay, let's create domain-specific questions that are so complex that even having internet access does not help you answer the question. You have to be a decades-long expert in this subject. You have to be a world-renowned subject matter expert in this particular domain. So the way that the dashed lines is PhD's inside specialty. So basically, let's just imagine that you are a cell biologist. You're a PhD in cell biology, and you're like, okay, I am a world-leading expert in cell biology. How good is this model compared to me? O1 was really, really close to a human domain expert. O3 went sailing past human domain experts. And then, as a control, they said, okay, let's make sure that it's not just a matter of education. Let's actually make sure that it's actually measuring specialty knowledge. And so the green dashed line here is you just take a random PhD and say, okay, here's a question from something other than your discipline. how well do you score on it? So someone who's already smart, because remember the average PhD has an IQ of about 125 to 130. So you take someone who's already like 1 to 2 standard deviations above average intelligence, they still only get 34%. So then you get this huge 50% bump by being a domain expert. And then O3 goes sailing past that. So what this implies to me is, because here's where I'm reading the tea leaves. If the information is not on the internet, then that also means that the information is not in the training distribution, which means that O3 was able to reason from first principles and other tangentially related background knowledge to still solve problems. It's like, well, I know this cluster of facts, and you're asking me this question that I have never seen before, but I can reason my way to, in 88% of the cases, the correct answer. That is super intelligence. I mean, just full stop super intelligence. And we're not even looking at the frontier math scores, by the way. And because someone out there on the internet said, you didn't even count the frontier math scores. I'm like, you're right. So that's going to be a topic for another day. So this is where we're at. This graph here shows how we got here. Now, this was shared by someone named Louis Peterson. Anyways, sorry, it's all up there on the tweet. So this is the training mechanism of how we got here. This is what Ilya saw. We are like 95% certain this is what Ilya saw, which is why he was butting heads and said, no, we need to lock this down and we need to be safer. So think of model V1 here as GPT-4. And then they said, oh, what if we just retrain GPT-4 to do inference time compute or test time compute, which is the reasoning? And so then it's like, oh, cool. Well, that actually made it act like it was 1,000 times smarter. Okay, so let me take a step back and explain what I mean by that. Test time compute or inference time compute effectively makes the model act as if it was trained on 1,000 times more data, give or take. So that was one of the ways that, and this came out like a year or two ago, they were like, oh yeah, like this is how you can overcome the data wall. You just let the models think for longer, which everyone who's been working in cognitive architectures and agent frameworks is like, well, duh, you have the models talk to each other and they can figure stuff out. What OpenAI did was they basically compressed a multi-agent framework into a single model. And I didn't fully appreciate that at the beginning. And by the way, the Raspberry team is still working. So make sure that you look up Raspberry over on, I'll make sure the link is in the description, if you want to fund it. Anyways, moving on. So with test time compute or inference time compute, you can basically get a model that acts as if it is much larger and smarter than the base model. Then you do a second process called distillation, which says you take that new gigantic model and you compress it into a smaller student model, and I'll show you how that works in a second. Rinse and repeat. This is the oscillation. So you do distillation, test time compute, distillation, test time compute. And by the way, you can keep synthesizing functionally infinite new information and new insights from this by using first principles. So how does that work? So this is the process of distillation. If you've seen chain of thought reasoning, that's test time compute. This is distillation. So you have a large model. So this is a large frontier model. And then you say, hey, why don't we just compress this model into a smaller model? And so you end up with a much smaller model that actually ends up smarter. This is the thing that we're not really sure about, but it's to me, it seems like this is actually basically how humans learn, which is, you have a student who learns from a bunch of different teachers, and then the student ends up knowing things better than the teachers because the teachers spent, decades learning and crystallizing that information and compressing it and transmitting it to the next generation. The fact that this works in language models, I'm not saying that they're copying humans. I'm just saying that's a metaphor. That's a very interesting parallel. So you have a teacher model teach the student model. The student model ends up being smarter and more efficient. Sounds like a generational thing, right? And so that's what we're seeing here. So you have, the old fart model, does all of its hard work, does its homework, eats its Wheaties, and then gets compressed into a new student model. And so you see model V1 plus compute, and that creates a new model. So then Model V2 grows up and teaches the next generation. So you see how we almost have this evolutionary path of AI. That is why I am like losing my mind, and that's why I'm like, okay, it's time to come back. Now, I also have on this the scaling laws, which is not necessarily as important because this really underscores what's happening. Now, before we proceed, I want to point you to my new link tree. So it's linktree / Dave Schaap. Link is everywhere, but it's got pretty much everything that I'm doing. So YouTube, where you're watching this right now, Twitter, Substack, Patreon, school. So my New Era Pathfinders community, I'm rebuilding it. And the reason that it just real quick, this is my AI learning community. And the reason that I'm restarting it is because my last mentor, she was great, but it was just not, she was not leading me in the direction that I really needed to go. So rebooting that, starting from scratch. I have a bunch of other YouTube channels and a whole bunch of other stuff. So anyways, back to the show. This is, I think, where we'll end up today. So this is another benchmark where O3 just takes it to another level. So this is the SWE benchmark, the software engineering bench. And this is bigger than people realize. Basically what I said in my tweet is like, I don't know why people aren't freaking out about this, because this is entering into like the top 10% of all developers in a single model. And remember, the GPQA, the SWE benchmark, the Frontier Math benchmark, that's all being dominated by a single model. This is beyond human polymath level. This is like take a human with an IQ of 145 and give them a millennia to read every book and take every class. That's the level of performance that we're seeing here. Is that level of compression of knowledge and cognitive capability. So really what we're heading for is what I call a period of cognitive hyperabundance. Like, I cannot stress enough what this means. And that's why I say superintelligence, my definition of superintelligence is when human intelligence is no longer a consideration for anything that humans want to achieve or do. In the same way that physical machines made the limitations of human strength no longer an issue. Like, if you want to get something to the moon, build a rocket that can launch it at the moon. Like that, they generate what, like 2.5 million horsepower or something like that to get to the moon. So we figured out physical force. We figured out kinetic force. Now we're figuring out cognitive force. And it like the long-term ramifications of this cannot be overstated. And so where I'll end today is I've actually come up with what I think, and this is not financial advice, this is not career advice, but I think that that cybersecurity is probably going to be a very safe job for a long time. And the reason is not because AI won't be able to do cybersecurity better. It's because you'll always want someone in the analog space with your hand on the kill switch. And so if you're looking for a job to get into, I would say that cybersecurity is probably not a bad choice to look at. Because think of it this way. You're going to want humans physically in the data centers on their on the EPO switch. So EPO is emergency power off. So if the call comes down, think of like, the Cold War stories of like, the people in the nuclear, ops centers, you've got your lieutenant colonel or your lieutenant general with his hand on the kill switch. We're going to need the same thing for data centers pretty much forever, as far as I can tell. And you're going to have AI actors alongside the human actors, because, and here's the thing, is AI can get hacked in a certain way, and humans can get hacked in a certain way, social engineering and that sort of thing. But together we can kind of like watch each other's backs, right? So you have your AI cybersecurity expert, and then you have your human cybersecurity expert, and they're going to be compensating for each other's weaknesses, at least for the foreseeable future. And it might be that that's the kind of job that you just legally require. Say, you know what? For every data center, you need at least 5 humans in there capable of hitting the kill switch. I wouldn't mind having that as a law, but time will tell. So anyways, thanks for watching. Cheers. It's good to be back. And yeah, let's see where it goes.